All right, we're going to graph the third function, trig function, the tangent. Now, in our course, we're only going to graph sine, cosine, and tangent. Next year, you will graph the reciprocal functions. We're just responsible for the basic trig function, sine, cosine, and tangent. However, we will be shifting these things around. We will be doing vertical shifts, horizontal shifts, and that kind of thing. And we've already done the amplitude change. All right, now, I think it's better to see this as we do it. Here's the facts behind it, but we'll go back and verify all of this stuff. In a tangent graph, you are going to have asymptotes. So remember, we're going to have vertical asymptotes because we have undefined values for tangent. That's where it's coming from. Okay, so let's graph this. Let's look at our chart. And now notice our chart's a little bit different. We're looking at the pi over 4s. Because remember, what is the tangent of the pi over 4 family? Square root of 2 over square root of 2 over square root of 2 over square root of 2. Square root of 2 over 2 over the square root of 2 over 2 is 1. So they're easy things to graph. So it helps us with our pattern. So here's the ones where we're going to graph the 45s in the tangent family. All right, let's go back and look at our unit circle, going backwards again because we're starting at negative 2 pi. So at negative 2 pi, which would put us here, right? We're going around, puts us here. What is the tangent at negative 2 pi? Which one goes on top? When I say tangent, you have to think y over x. So 0 over 1, which is 0. All right, we're doing our 45s. What's the tangent of negative 7 pi over 4? 1. All right, we're going back around the circle. So now the tangent of pi over 2 is undefined. So that's going to be an asymptote. All right, can you use the rest of the circle to fill out that chart? Going this way, and then we're going to turn around and go counterclockwise. Okay, so at negative 2 pi, we've got a tangent of 0. At negative 7 pi over 4, we have a tangent of 1. At negative 3 pi over 2, we're undefined. At negative 5 pi over 4, it's negative 1. At negative pi, we're at 0. At negative 3 pi over 4, we're at positive 1. At negative pi over 2, we're undefined. At negative pi over 4, we're at negative 1. 0, we're at 0. All right, now you're going to go counterclockwise. So at pi over 4, we're at 1. At pi over 2, we're undefined. 3 pi over 4, we're at negative 1. At pi, we're at 0. At 5 pi over 4, we're at 1. 3 pi over 2, we're undefined. 7 pi over 4, we're at negative 1, and at 2 pi, we're at 0. Here again, we're going to memorize a pattern. You should never have to do the charts again. I'm just showing you the charts where these things are coming from. You're going to be doing your patterns. 0 is 0. You good? Okay. All right, now here's how you find your asymptotes. All right, now your b is the coefficient in front of your x. So in this case, my b is 1. So to find the amplitude is going to be pi over 2 times the absolute value of b, which is just pi over 2. So that means we're going to have amplitudes, an amplitude at plus or minus pi over 2. And then on the notes above this, it said at every odd multiple of that. So this is 1 pi over 2. That means we have another asymptote at 3 pi over 2. Another asymptote at 5 pi over 2. Every odd multiple of pi over 2. That make sense? Get nothing? Okay? So all tangent graphs are going to have asymptotes. Sine and cosine doesn't, but tangents always have asymptotes. So draw in your asymptotes. So at negative 3 pi over 2, at negative pi over 2, at positive pi over 2, and at positive 3 pi over 2. If the graph continued, we'd have more asymptotes. All right, let's graph this thing. So at negative 2 pi, we're at 0. All right, negative 7 pi over 4. These are 90 apart, right? So at negative 7 pi over 4, that's a 45, so it's halfway in between my marks. So at there, I'm going to go up to 1. So this piece of the graph, because of that asymptote, is looking like that. It just shoots up by the asymptote. Right, so it keeps on going forever upward, but it can never get to negative 3 pi over 2 because that's an asymptote. It'll get really, really close, but never quite get there. Yes, sir?
You were saying that if the graph continues, there's more asymptote.
Right, every odd multiple.
Okay, and then if you were to, like, if you're talking about changing p with, like, a sine and cosine and all, I'm guessing changing the p would be...
It's going to change, if we're going to change, it's going to change your asymptotes too, right? Because this little formula, pi over 2b, if b changes, if the coefficient of the x changes, it's going to change where the asymptotes happen. Okay? All right, so this piece of it. So now we're at our 40, so there's our undefined. So at negative 5 pi over 4, we're down at negative 1. At negative pi, we're at 0. And at negative 3 pi over 4, we're up at 1. Because our 45s are splitting those distances because our scale is by 90. That's why the halves are 45s. Okay? All right, the middle piece. So we've got, where were we on here? So there's my undefined at negative pi over 2. That's my asymptote. So at negative 4 pi, I'm down at negative 1. At 0, I'm at 0. And at pi over 4, I'm up at 1. So there's my next piece of my graph. So you see how the pattern's continuing. All of these have a pattern that continues. All right, there's another asymptote, and my undefined at positive pi over 2. So at 3 pi over 4, I'm down at negative 1. Pi, I'm at 0. 5 pi over 4, I'm up at 1. And you just have to graph as just as big as your graph goes. All right, so here, my other undefined at 3 pi over 2. At 7 pi over 4, I'm down at negative 1. And at 2 pi, I'm up at 0. And that's just when my graph stops there. That's why I'm stopping. All right, now, where does the pattern repeat on this? What's the period of this thing? Look at 0. We're starting at 0 to pi. Right, there's your pattern. Okay, so that's why the period is pi. Because this pattern repeats every pi. So I went from pi to 2 pi. There's that pattern again. So all the period is saying is when does it repeat itself? How far before it starts repeating itself? All right. So that's the basic, that's the parent tangent graph. And you got to, like I said, here again, you got to memorize. Now, we don't have an Ohalo or Hala for the tangent. You can come up, I don't know, negative 1, 0, 1. Come up with something, but lol, negative lol. Yeah. Yeah. Tangent 101. Okay, there you go. Tangent negative 101. Okay. That green wasn't so good on this blue, so let's. All right, let's graph it. All right, so here, notice we've got our A is 2. So A is 2, and B is your coefficient in front of the X. We're going to change that in a minute and see what happens. All right, B here is 1. What you want to do before you start graphing these things is figure out what your asymptotes are. Your asymptotes, and like I said, it's about memorizing a formula again. Your asymptote is given by pi over the absolute value of B. This is at the bottom. Okay. So that means, I'm sorry, 2B. 2B. Period's pi over B. The asymptote is given to you by pi over 2B. So that means that we have an asymptote at pi over 2. Now, odd multiples. So what's my next asymptote? 1. What's the next number? What's the next odd number from 1? 3. So 3 pi over 2 is an asymptote. 5 pi over 2. 7 pi over 2, 9 pi over 2, keep on going. Yes? B's right here, the coefficient in front of the x. Okay? A is that, A is 2, B is 1 in this case. All right, so what's going to happen? What is that A going to do to our height? Instead of being at 1, it's going to move up to 2. So we're multiplying all the y values times 2. All right, go ahead and let's put in our scale, and let's put in our asymptotes. Right now, we're still going to be counting by 90s. We will eventually change those scales to fit our questions. That's what's coming in the future. All right, so we're going to have pi over 2, 3 pi over 2, pi, and, no, I got them all backwards. Wait a minute. All right, pi over 2, pi, 3 pi over 2, and 2 pi. And over here, we're going to have negative pi over 2, negative pi, negative 3 pi over 2, and negative 2 pi. I'm going to be 1 and negative 1. It's very important on these things because graphs cannot tell if your graphs are right unless you have the proper scale. You have to write the scales in because these scales will be changing in the future to match our questions. All right, always drawing your asymptotes first. I'm doing blue now. All right, so my asymptotes are at positive pi over 2 and the negative one. Always has a mate. At 3 pi over 2 and at negative 3 pi over 2. Now 5 pi over 2 would be here. So there is another asymptote there and here just because our graph goes a little more. It depends on how far your graph goes out. You got to fill up your whole graph. All right, I always start in the middle. That's when I get my pattern set up, and then I just continue my pattern. So I'm going to start at 0. So remember, it was at tangent of 0 is 0. All right, go to 45. At 45, we were parents up 1, but because of that 2, we're going to go up 2. All right, at negative 45, we're going to go down 2. All right, so there's my initial piece, and you're just going to repeat that on between each of my asymptotes. So my 0 is at pi. Half the distance go down 2. Half the distance and go up 2. Please stop me if I say something that doesn't make sense. All right. My 2 pi is my 0. I'm going to half the distance and go down 2, half the distance and go up 2. So there's my other piece. And then I got to go finish my other side. My 0's at negative pi, half the distance and go down, half the distance and go up. And then finally, my 0's at negative 2 pi, half the distance and go up, half the distance and go down. All right, so there's my graph when I've stretched it up 2.